see. A high school in a small town always has its homecoming day and parade on the first Saturday in October. Okay. For historical reasons, it has been determined that the probability of rain during the parade is 0.24. Okay, so they looked at the last 20 years and that's how many times, what fraction of the time it rained. Amina will be attending Howard High School for the next 4 years and plans to play in the marching band for 4 years. So we're being asked, what is the probability that it will not rain on the homecoming parade on Amina's first year? Okay. So I'm going to write down the essential thing, which is the probability that it rains, and that's 0.24. And now I'll take control and I'll show you. Show you this guy. Right. Now, the first question asks, what's the probability that on the first year it doesn't rain? These are called complementary events, what we're dealing with here. Rain and not rain. If the probability that it rains is 0.24, then the probability that it doesn't rain is going to be 0.76. Can you see where that 0.76 is coming from? What did I do?
Is it the weeks?
Nope.
No?
No. What's the connection between these two numbers? They're not random. They are very closely connected to each other.
Mm.
Here we go. Last chance.
I have
To get from this number to this number, you take the first number away from 1.
Oh.
They're called complementary events.
Okay, I'm gonna write that down.
And they have a funny notation. If I remember, the different textbooks have different notations for them. I think this book puts a little C up there, don't they? Have you seen that?
Yeah.
Right, okay, so the little C is for complementary. So if this guy is 0.3, that guy will be 0.7. And complementary events are the thing and not the thing. So rain and not rain, boy and not boy, you know, that kind of combination. So there's your answer to your first question. What's the probability that it will not rain on the first year?
Oh, okay. That was okay.
Now, the second one is much more complicated. What is the probability that it will not rain on any of the homecoming parades for the 4 years that she's there? So in other words, she is the luckiest girl in town. She never gets rained on for the entire 4 years that she's there. So what's that going to look like? Well, it's going to be the probability. I'll use NR rather than write that sentence. So it's not raining on the first, and then not raining on the second, and then it's not raining on the third year, and the final senior year, it's still not raining. And we are trying to find the probability of this and this and this and this. So the first, the second, the third, and the fourth year. And there is a way that we can do that. Since these 4 different years are independent events, we are allowed to separate them and multiply each together. It's called, I believe, at least in the textbooks I have seen, it's called the multiplication rule of probabilities. What the multiplication rule of probabilities does is it says that if you're doing more than one event, something followed by something, followed by something, and these events are independent, in other words, it doesn't matter what happened here, it has no effect what happens on the second year, then you're allowed to multiply these probabilities together. And these particular probabilities all happen to be 0.76. Which in mathematics, we have a shortcut for that. We write a little power of the 4. So I would go here and I go 0.76 raised to the power of 4. And then I get a really ugly decimal, but they only want 3 decimal places. And that rounds off the 3336, rounds off to the 334. And so that is a probability that it doesn't rain
How do you know?
any of the 4 years.
How do you know when you multiply? Like when to multiply?
In this story, I know it's multiplied because it is 4 years. One happens, and then the next happens, and then the next happens, and it's next. It's a sequence of independent events. It's not, well, the only other situation I can think of would be that sometimes you add things together rather than multiply them. But if I was doing an add story, it would be more things like cards, where I said, what's the probability you get a king and or a queen, you know, something like that. Then I would be thinking about adding those together. But that's one card coming out of deck. It's not 4 cards coming out of deck. It's just one single event that is made up of a combination of things happening. These are really 4 events, one after the other. So that's how I would be able to tell.
Okay.
Now,
makes sense.
We still have question C. And question C, that's probably going to be the worst looking one, just scanning it. What is the probability that it will rain on Amina's parade at least once during the 4 years? And that is going to be a hard one to do. This one is going to be the, you know, you'll need your thinking cap on. At least once in 4 years involves a lot of different things that could happen. At least once it rains, right? I guess I should put R. Right? It rains at least once. That could be that it rained on the first year and not the other 3. Or it rained on the second year or not the other 3. But if you try to write down all the ways at least once could happen, at least once also allows it to rain twice, doesn't it? And that means it could rain 3 days, 3 times. And one particular horrible combination is it rained every one of the 4 years. Now, if I tried to write down all the different ways that I just talked about and did it this multiplication way, it would take me forever and a day. There'd be something like 15 at least different things I'd need to get. And each one of them, I would multiply them together and get an answer. And then I'd add them all up because it's a big event. So I am not going to do that. This is the thinking, sneaky part. I am going to find the exact opposite of this event. What's called its complement. Now, the opposite of it raining at least once in 4 years, right? The exact opposite of that then, I'll do it red, is it doesn't rain at all. Let's see, we got that. The exact opposite of event from raining at least once in 4 years, right? The exact opposite of that is that it doesn't rain at all. Are you with me?
Yeah.
Okay. Now, this probability I can find because this is going to be the probability of that guy. Won't it be not rain, not rain, not rain, and not rain?
Okay.
We've already got the answer to that, so I'm just going to use that answer. 0.334. And then you might think, hey, great, I've done it. Well, not quite. You're almost there, but not quite. I haven't found this probability. I found the exact opposite of it, called its complement.
Okay.
But that was pretty easy to calculate, right? Because it was
Yeah.
only one multiplication. Now, to get the answer, what is the probability of this event when I know that its complement is 0.334? Well, we are going to use that property. Isn't the complement of event, isn't its probability 1 minus the other thing? So if one of them is this, won't that be 1 minus this? And so the answer to the original question is 0.664. What you get when you take 0.334 away from 1?
I get 0.666.
Did you catch that deliberate mistake? No, that was me being careful.